Hello students, after completing the power, roots and logarithm of complex number, we'll move forward with the trigonometric, exponential and hyperbolic function. Now to begin this, what we need is the simple Euler's formula which we have studied in the first video lecture while discussing this. See, when I taught you exponential form from the exponential form, what we used, the complex number z is x plus iy and z is also r into bracket cos theta plus I sin theta. So when we derive this, we are reached to the expression called as cos theta plus I sin theta is nothing but e to the power I theta. That was Euler's formula or Euler's formula. So we'll begin this topic with this formula itself and we will be able to get all our trigonometric functions like sine, cos, tan, okay, sec, cosec and cot. Okay, that's what our first job. So what will I do? I'll begin with the Euler's formula or the Euler's formula. So what does my Euler's formula said mentioned as I just now told you is cos theta plus I sin theta is equal to e to the power I theta. Okay, this is our starting statement. Correct? So I'll write it in this fashion. E to the power I theta is cos theta plus I sin theta, equation number 1. Okay. Now suppose I replace this theta by minus theta, nothing much complication. Okay. What will this will give me? E to the power minus I theta, okay, is equal to cos of minus theta. Wherever you see theta, just replace by minus theta, okay, plus I sin of minus theta. Correct? So everybody knows the value of cos of minus theta is cos theta and sin of minus theta is minus sin theta. Okay, this we study in 11th and 12th standard. Okay, so with this, what is the equation number 2 will become? Equation number 2 will become e to the power minus I theta is cos theta minus I sin theta. Fine. So we'll take equation number 1 and 3. Okay. So if I try to work on these two equations, okay, if I add equation number 1 and 3, so I can say add equation 1 and 3. What will I get? This term will get cancelled, okay, and I'll get 2 cos theta. So I say when I add them, I get e to the power I theta plus e to the power minus I theta is 2 cos theta. Fine. So this gives me cos theta is equal to e to the power I theta plus e to the power minus I theta divided by 2. Fine. Now once I get this value, what is my next job? After getting this, try to get even the sin theta. Now to get sin theta, what I'll have to do? I'll have to subtract these two equations. Subtract, so this will get cancelled and this will become double. Okay. So if at all I subtract equation number 1 and 3, I can write e to the power I theta minus e to the power minus I theta is equal to minus is equal to 2I sin theta. Right? Is equal to 2I sin theta. So this will give me how much? Sin theta is equal to e to the power I theta minus e to the power minus I theta divided by 2I. So this is my equation number 4 and equation number 5. Okay. Now after getting cos and sin, which are basic, I can easily write tan first. Okay. So therefore we can say my tan theta is equal to sin theta by cos theta. Sin theta is e to the power I theta minus e to the power minus I theta divided by 2I into 2 divided by this term will come over here plus e to the power minus I theta. So cancel 2. What we can write? E to the power I theta minus e to the power minus I theta divided by I. Correct? Divided by I inside the bracket e to the power I theta plus e to the power minus I theta. This is my equation number 6. So I got, by writing my simple Euler's theorem, just replace theta by minus theta, I got second term add them, I got cos value, subtract them, I got sine value, take sine by cos, I got tan value, so I reached over here. Okay, now it's very simple for me to write cot theta immediately. Okay, so what is cot theta? Exactly reverse of this, so 1 upon tan theta. So I can write I e to the power I theta plus e to the power minus I theta divided by e to the power I theta minus e to the power minus I theta. This is my equation number 7. Okay, I got cot also. Now to get sec and cosec. Okay, sec how will I get? I'll take sec theta first. So sec theta will be 2 divided by 1 upon cos theta. So 2 divided by e to the power I theta plus e to the power minus I theta, equation number 8. Fine. And cosec will be 1 upon sine. So here I'll write cosec theta is equal to 2i divided by e to the power I theta minus e to the power minus I theta, equation number 9. Correct? So this way I got all the values of my trigonometric functions starting from sine, cos, tan, cot, sec and cosec. So starting from equation number 1, I reached to equation number 9. Now what we'll do next, we'll try and replace this real theta, okay, in the equation e to the power I theta. Replace this theta by complex number z. Okay, means what? I'll just tell you what I'm trying to get it. So replace the real theta, okay, by complex number z. So what will I write? The Euler's formula will become how much? This I'll write e to the power iz. Only I am replacing theta. I is as it is. So e to the power iz will be cos theta will be cos z. Replace theta by z. Right? Plus I sin z and e to the power minus iz, this equation minus iz will be cos z minus I sin z. Fine. So with the complex variable z, the relations of sine, cos, etc. are similar to what I got earlier, just equation number mentioned from 1 to 9, these equations. Okay, so how will be able to, I'll write first sine z, like I wrote the value over here, so of sine theta. Okay, so that will be nothing but what? Sine z will be e to the power iz minus e to the power minus iz divided by 2i. So what I did here and here, just replace this theta by z. Replace theta by z, rest all as it is, nothing had changed. I just replace theta by z, I will get all such expressions again. This is just sine, I can write cos, then tan, then cosec, sec and cot. Done, which is almost similar. Correct? With this, we'll move to the next one, which is hyperbolic function. So in hyperbolic, what you need to prove basically, in hyperbolic function, what I'll do, I'll write the value of sine z, which I just now wrote over here. So sine z is e to the power iz minus e to the power minus iz divided by 2i. So I'll write this value as it is over here, e to the power iz minus e to the power minus iz divided by 2i. Same way I can write even for the cos z. What is cos z? In the same manner, like here I wrote, replace z, replace theta by z. So I will write e to the power iz plus e to the power minus iz divided by 2. Okay. Now suppose this is equation number 1, equation number 2. Now if the complex number z is purely imaginary, okay, means what? We write complex number z is x plus iy, where x is my real part, iy is imaginary part. Now what I am making the comment, that if the complex number z is purely imaginary, so x is 0, the real part is 0. So I'll say, if it is case, if z is equal to x plus iy, but the complex number z is purely imaginary, which means z is equal to iy, then x part is 0. In that case, what will happen? We'll write z is equal to iy in the equation what I got, equation number 1 and 2. Okay? So I'll write sine of iy, because I said z is iy. Then sine of iy will be e to the power I, replace z by iy, replace z by iy divided by 2i. Okay, so this will become how much? E to the power I square y minus e to the power minus I square y divided by 2i. But we know I square is minus 1. Okay, so this will become how much? E to the power minus y, because I square is minus 1, and minus I square will be plus 1, then divided by 2i. E to the power minus y minus e to the power minus y plus y divided by 2i. Okay, now suppose I take this term first, which means minus sign is out. Okay, so I'll write minus sign is out, I square is minus 1, this is as good as I square. Are you getting it, what I am trying to tell you? So I want to write this term first. So this term is got a minus sign, so like this is the term, I mean divided by 2i. Okay, but I don't want to write this minus sign, so I can write I square over here. Okay, so I'll write, instead of minus sign, I square e to the power y, okay, plus e to the power minus y divided by 2i. But this I can write in I into I, e to the power y plus e to the power minus y divided by 2i. Cancel one I. Getting it? So therefore, what is my, okay, I think I made a mistake in sign. Yeah. So this is minus, yeah, okay, and this should be this is minus now, yeah, so this should be minus, this should be minus. Okay, so therefore finally what I'm getting now, sine of iy is nothing but I into this, I will remain as it is, one I gets cancelled, fine. So 1i e to the power y minus e to the power minus y divided by 2 is my new value. Fine. Similarly, we'll do for the cos y also. So cos of z, what I said, replaced by iy. So this will become e to the power I into iy. I into iy plus e to the power minus I into iy divided by 2. Okay. So this will give me how much? Cos of iy is, this is I square y. I square is minus 1. So minus y plus e to the power y divided by 2. This is as it is. Only I can write cos of iy is e to the power y plus e to the power minus y divided by 2. So this is the way I got the value of sin iy and cos iy. Okay. Now these functions are basically called as the hyperbolic functions. Okay, and how do you write this hyperbolic function? We write sin, S-I-N-H z, or cosh z. Keep a gap between S-I-N-H and z, or C-O-S-H and z. This is called as sin z and cosh z. Fine. So what I can mention, this cos of iy will be called as cosh z, and that is nothing but e to the power y plus e to the power minus y divided by 2. Similarly, sin z is equal to e to the power y minus e to the power minus y divided by 2. Okay, so e to the power y is e to the power minus y divided by 2. This is my value, and don't forget the I. Okay, so this is the way I got the value of my sine and cosine function, which are the hyperbolic function over here. Now once we know these two, we can very well go ahead and write the value of tan hyperbolic z Either you say hyperbolic z or write like cosh, sine, tan, okay, h has to be there. So if at all I want to write down the value of the tan function, how will I write? I need to write tan z, tan hyperbolic z. So that will be sine hyperbolic z divided by cos hyperbolic z. So what is sine hyperbolic z value? You know that. Okay. So substitute the value and you will get the answer. Same way, suppose I want to write cosec hyperbolic z, I just write 1 upon sine hyperbolic z. And as far as sec is concerned, sec z should be 1 upon cos h z, that is cos hyperbolic z should be the formula. So substitute the value what we got just now over here and we can carry on with the relation. Okay, so it is as simple as possible. So till now what we just used what is called as the Euler's formula, and we could go till that much statement. We could begin with this statement and we have reached till the hyperbolic function, till the level of tan hyperbolic, cosec hyperbolic and sec hyperbolic also. Okay, so it's not that difficult to prove what is happening over here. Clear? Now we will have some identities, okay, relating to all these sine, cosh, tan and so on. Okay. Okay, here when I define this cosh and sine, as I mentioned z here, even here z should appear. I made a mistake, by mistake I wrote y only, it should have been z. Okay, when it is sine of iy, then y is okay, but moment I shift from, when I'm defining these are the hyperbolic function, I need to replace them by z. Okay, just a small, I think, typo mistake I can say. Clear? So cos of iy, sine of iy, that is okay, but when I say z, so it has to be z over here. Okay, now we'll use this equation itself to prove the further identities. Okay, so further identities means what? I need only this relation. I need to prove sine of I theta is I sine theta and cosh of I theta is cos theta, and for this the basis is this equation. Okay, so what I can say, as the value of sine I theta, okay, how we have defined this value? Sine of I theta, we said e to the power I theta, okay, minus e to the power minus I theta divided by 2. Okay, now if we say so, then what is the next statement we write? We write I into bracket e to the power I theta minus e to the power minus I theta divided by 2i. Okay, so here what I did, multiply and divide by I. Fine. Now after multiplying and dividing by I, what is this part basically? This part is nothing but the answer basically. Okay, so here we will be able to write very clearly that sine of I theta is basically I sine theta. Okay, that's what is the simple logic I am trying to use it. See here, this is my sine z. Okay, so earlier as I mentioned, replace theta by z, that time we got the same values over here. So here we can see again replace z by theta, so I'll get this answer, I sine theta. So I could write sine of I theta is this formula, but if at all we multiply and divide by I, we get the equation which is similar to the sine theta. Therefore the first identity is sine of I theta is nothing but I sine theta. Okay, now we'll prove the second one. In second one, what we need to know? We need to know that the value of cosh of I theta is nothing but e to the power I theta plus e to the power minus I theta divided by 2. Here we want to prove cosh of I theta is cos theta itself. Okay, so the formula itself says everything, nothing we have to prove. So we can say, using z is equal to I theta in this equation. So what I did, this is cosh. So replace z by I theta. So replace z by I theta, e to the power I theta, so e to the power minus I theta by 2. This itself is my cos theta. Okay, so nothing much. I'll have to use my brain and we get the equation as it is. Now what is the third identity? Third identity is sin theta is equal to minus I sin I theta, or I sin theta is equal to sine of I theta. This we have to prove. Now to prove this identity, sin theta is minus I sin I theta, what we need to do, as we wrote the equation earlier, that sin of theta is nothing but e to the power z minus e to the power minus z divided by 2. Okay, so we'll try and replace z by theta. So replace z by theta gives me how much? E to the power theta minus e to the power minus theta divided by 2. Okay, now we try and use, this is plus sign, this is minus sign. So we know I square is minus 1, but minus I square is plus 1. So we'll introduce over here the term called as minus I into I theta minus e to the power, I need now the minus sign. So what will I do? I into I theta divided by 2. Okay, now this will help me what? This will help me to write the RHS clearly. So this will become how much? This will become minus I outside the bracket, and inside the bracket I have e to the power I times I theta, correct, minus e to the power minus I times I theta divided by 2I. So here also what I did, I wrote this term first, then I wrote this term divided by 2I. Okay, so this will help me in what? This will help me in writing the answer as the RHS. So looking at the RHS, I am framing and writing the term. So this will become minus I into sine of I theta. That's what is the beauty of this equation. So this is only 2I. Okay. Now same way, what will I do? I'll write the fourth also identity over here, which is cos theta is nothing but cos I theta. Okay, to do this, what we need to do? Same, replace z by theta. Okay, so what will I do? I'll replace simply cos theta is equal to, replace z by theta, so e to the power theta plus e to the power minus theta by 2. Same logic, I square is minus 1 minus I square is I square is minus 1 minus I square will be plus 1. Okay, so here what will I do? E to the power minus I into I theta plus e to the power I into I theta divided by 2. Okay, and this itself is nothing but my cos of I theta. So nothing much to break your head as far as cos is concerned. In sine, you need to be little careful as far as how you are writing the term. Done. Now the next term, which is little more, I should say, involved, is cos square. So cos square z minus sine square z is equal to 1. Okay, now to do this, I need to write the LHS properly. LHS, I need to write the cos value, then sine value, then square them, simplify them, and get the answer to be RHS to be 1. Okay, so we'll go over here. So what we can say first, the Cosh value. So what is the Cosh formula? E to the power, moment this is z, write z. So e to the power z plus e to the power minus z divided by 2 bracket square. Done. Minus. Now what about sine? E to the power z minus e to the power minus z divided by 2 bracket square. Done. Like here I use the value. Done. Now here we replace theta by z, we replace h by theta by z. Okay, that's what that is happening. Now here as I wanted z, so everything is in terms of z. Clear? So if at all I simplify this, what will I get? This is nothing but a to the power a plus b bracket square. This is a minus b bracket square. Okay? So even though you simplify this divided by 4 everywhere, so things will get, the answer will be as simple as possible. So this is nothing but a to the power 2z, correct, plus a to the power minus 2z. Okay? In between term will be e to the power z into e to the power minus z, will get cancelled obviously. Okay, and this is the first term. As far as this term is concerned, we'll write e to the power 2z minus e to the power minus twice e to the power z e to the power minus z plus e to the power minus 2z. Okay, divided by 4. Done. So if we try and arrange the terms properly, as far as the middle term is concerned, here I think I forgot to write 2. Okay, here the 2 is there. Now this e to the power 2z minus e to the power 2z will get cancelled. E to the power minus 2z with minus 2z will get cancelled. This is minus sign. As far as this term is concerned, e to the power z, e to the power minus z will get cancelled. E to the power, it will become 0. Same thing over here. This plus 2 and minus of minus 2 will become 4. So 4 by 4 will be 1. So RHS is proved. So this is the way we will be able to understand the identity number 4 is concerned. Clear? Now same way we'll do the normal trigonometric identity also, which is sine square theta plus cos square theta is 1. Next is sine square theta plus cos square theta is equal to 1. Now the trigonometric function for sine theta and cos theta we have by hearted now very well. So what is the value of sine theta? We have said e to the power I theta, correct, minus e to the power minus I theta divided by 2i. Done. And as far as cos theta, what I taught you is e to the power I theta plus e to the power minus I theta divided by 2. Okay. Now what is our duty? Just substitute the value, simplify, and we should be getting the answer. So go ahead. So e to the power I theta minus e to the power minus I theta divided by 2i bracket square plus e to the power I theta plus e to the power minus I theta divided by 2 and square. Okay. Now just now what I showed you, with that logic you can simplify and show that the answer is 1. I give this job for you to do it. Okay. Same way. This was my identity number, I think 4. Okay. 4 or 5. This was 5. Now even this you will prove. E to the power 2i theta minus to the power minus 2i theta, middle term will be minus, here the middle term will be plus. Okay, don't forget this I square will become minus sign. So work on it, you should be getting the answer. Now the sixth identity is what? Sine of 2 theta is equal to 2 sine theta cos theta. Same logic, we know the formula for sine theta and cos theta. Okay, substitute the RHS, okay, and see do you get the answer as it is, or what you can do, take this RHS, put the value and see do you get this. Anyway you should, because you do not know sine 2 theta value, so put sine theta cos theta and try to get the LHS. Okay, the answer sine theta cos theta is over here. Okay, do work on that also, should not be difficult one. And the seventh one is cos 2 theta is equal to cos square theta minus sine square theta. Even this should not be an issue at all. So right, we have cos value, square it, we have sine value, square it, simplify it, and we should be getting the answer. RHS should be, the LHS in this case should be the cos 2 theta. So these two will not be a difficult job, but until unless you try, you will not come to know is it easy or difficult. That is the reason I am giving this job for you to do it. But if you don't get it, no problem, we'll do it in the class. Okay, we might have the offline lectures from next week. Okay, we are also very excited to see you in the class and teach you. So let's see how things shape up about with vaccination and all. So by next week we will get the clear idea as far as what is happening. Till then this will go on. So work on this. Any difficulty, feel free to ask. Nothing to feel shy or how, and no ways, no worries. We'll work on it. Okay. So get this. Only one small topic is left, and the problems. There are plenty of problems in this first chapter. The topic what I left also is very small. So I might take the lecture tomorrow itself. I'll upload like morning today I did it. Okay, and we'll finish the chapter also. Along with that, we will finish the problems also. Okay, so it's not a big task left as far as the first chapter is concerned. First chapter has got plenty of problems, and as many you solve, you'll get more practice. Okay, so work on the theory well. There should not be any problem with the solving the numericals also. Okay, thank you very much. Go ahead.